Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for running your next app or experimenting with something you hear about on the show. When you're writing Python, you need a powerful editor to automate routine tasks, maintain effective development practices, and simplify challenging things like refactoring. Our sponsor this week, JetBrains, delivers the perfect solution for you in the form of PyCharm, providing a complete set of tools for productive Python, web, data analysis, and scientific development, available in 2 editions. The free and open source PyCharm Community Edition is perfect for pure Python coding. The PyCharm Professional Edition is a full-fledged tool designed for professional Python, web, and data analysis developers. Today, JetBrains is offering a 3-month free PyCharm Professional Edition subscription for individuals. Don't miss this chance to use the best-in-class tool with intelligent code completion, automated testing, and integration with modern tools like Docker. Go to www.podcastinit.com/PyCharm and use the promo code podcastinit during checkout. You can also visit the site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. And to help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host, as usual, is Tobias Macy, and today I'm interviewing Jeff Reback about Pandas, the Swiss Army knife of data analysis in Python. And Jeff, could you please introduce yourself?
Sure. So my name is Jeff Reback. Let's see. I started off, I graduated from MIT with a degree in computer science. But for about 20 years, I actually worked at Deutsche Bank as a quant trader person. And so it's interesting. I started off using Perl of all things, which is kind of like the Swiss Army knife of data parsing languages. And I did this for quite a long time, up through about 2009, when I switched to using Python. And for the last couple of years, actually, I've worked at Continuum Analytics, basically doing some consulting for people, in Python and using Pandas and big data type of things.
And how did you first get introduced to Python?
So I basically decided in 2009 that Perl was a dead language. I really liked it, actually, but the world was moving on. So I decided to just switch over from Perl to Python. Ironically, I actually hated Python. I was like, oh, white space. That's just terrible. But then, actually, after just a little bit of usage, I was really, really happy with it. And that lasted about a year or so before I started using Pandas. This was way back, it must have been Pandas like, 0.1 or 0.2 or something like that. I was working at a hedge fund at the time, and I started exploring with Pandas. I needed something to manipulate my data with. It just became pretty easy, and so I continued on.
Yeah, it's interesting how a number of people coming from Perl either go to Python because it's pretty significantly different from it, or they go to Ruby because of how much of Ruby was influenced by Perl to begin with. So interesting to see where people lie on that continuum.
Absolutely. Ironically, I didn't discover Ruby till much later, and I was already hooked on Python. And then just continuing on my little story, so I started using Pandas, and I was like one of the really, I'll say, first users out in the real world, and I just liked it so much. I started, doing all my stuff in it, and I was like, okay, hey, this is kind of interesting. I had never contributed to any open source project before. Keep in mind this was back in 2010, and over time I said, oh, hey, I wrote this nice little. Well, my first contribution to Pandas was actually some integration with the PyTables library. Actually, I needed a way to store lots of data. I had my data frame in memory. I needed to store it on a disk. So I said, oh, hey, I'll write this little interface. And it was, looking back at that code was not the best in the world, but it got the job done. And I eventually took this code and I pushed it up. And Wes, who's the original author of Pandas, and we'll talk about that in a second, we actually, talked a little bit. And I was like, oh, this is kind of interesting contributing to open source. I said, oh, let me push some code up and it works and people can use it. Great. That went on for a couple of years, and eventually I started contributing more and more in my spare time. I had a little bit of spare cycles. I was running some model or doing some analysis or whatever. And I said, oh, I'll just go look at some bug and go fix that bug. And it became more and more interesting over time to do that. I'm just going to digress a second and give you a little bit of the background of Pandas. So it was originally started in 2008 by Wes McKinney, who was at AQR at the time. This is a big hedge fund. Yeah, and so he needed a way to marry the disparate systems that existed. And, as anybody who has to deal with messy data, some data you have in CSV files, or some data you have in SQL, some data is in a binary format sitting out there. And what you want to do is read it all in and marry this data together. And then the key thing is make this data line up with each other. And this is, of course, it's not a finance specific problem, but a lot of the things that you actually want to do with the data, namely like time series type operations, are finance specific. But what Pandas came out of this whole scenario where you could take some of your existing code, because Python connects pretty readily to your existing C or C++ code, and you could read in your data, use your own libraries to do analysis for it, and read from SQL and read from your CSV files, put it all in memory, align it, and then just easily do your manipulations with it. So this was the rationale for the creation of Pandas. And over time, I'd say the next 3 or 4 years, as the library was maturing, it became easier and easier to use. It became more flexible and became just more friendly. That's what I view as Pandas, why Pandas became successful, actually. A lot of people were essentially forced to create their own version of Pandas, to do this type of manipulation. And over time, more and more people started to see, oh, hey, there's this nice open source library that's out there that allows me to, in a very easy way, using the easy language Python, in a very readable way, to be able to read your data in and with just a small number of commands, manipulate it. And so this became very popular with lots of people, over the years. So that's what I'll say how Pandas sort of grew up. And now the next stage of Pandas was, I'll say, from maybe, 2012 through now, where it was being picked up by not only the finance companies and people who worked at finance companies, but also many, many other disciplines. We have had communication, through bug fixes and bug reports from so many different disciplines, everywhere from, physical science type people to neuro people, to people who do consumer products, advertising people who are taking all this massive advertising data and want to parse it. So a lot of different, Pandas is a very large library, and people take from it and use certain parts of it. So this is why I think Pandas has risen in the last few years to become, I'll say, almost dominating the basic data wrangling in Python. And that is because people can find what they need in it. It's just a giant toolbox. You mentioned at the very beginning of this podcast, it's the Swiss Army knife. Absolutely. I think it's more than a Swiss Army knife. It's the hammer and it's the screwdriver. It's all the tools rolled into one. And people can take from the toolbox the tools that they need and want. One other thing I'll mention is that the very fact that it is open source means it's very, very high quality. Pandas is very well tested by lots of different people. We have something like 15,000 tests now that run on every single commit. And all of these tests came from bug reports from, people who were running the code and doing something, and they found some edge case or whatever, and they contributed back. At the very least, they contributed back an issue, or maybe they went one step further and contributed back some actual code to test that issue. So I think Pandas actually is very fortunate to be used actually by lots and lots of different disciplines. It gives it a lot of flexibility and it makes it very robust. And so this is a great example of software that has grown in almost a grassroots fashion. There was no central vision. There was a central vision, but that can only take you so far. There's been a lot of, we'll say, even backfilling of features and, from other languages. Pandas had a lot of influence originally from R and even from things like Excel. Excel is actually very interesting use case because tons and tons of people obviously use Excel. And at some point, they're going to hit the limits of Excel. And they're going to be like, oh, let me look at this Pandas thing. It can do a lot of what Excel does in a very natural way. It's different, of course, but it's also very complementary. And this is just a good thing.
Pandas has definitely become quite ubiquitous in a lot of areas, and it's become almost the de facto introduction to doing data analysis in Python. As the first step is to import your data into a Pandas data frame. And I've actually spoken with a few people who have had the experience where they've come into Python specifically to learn Pandas, and in some ways they don't even realize that that Python itself is its own independent language, because they just say, "Oh, I write Pandas," similar to the way that I've spoken with a lot lot of people who come into the Ruby language by way of Ruby on Rails and say, oh, I'm a Ruby on Rails developer, not even really realizing that Ruby is a language separate unto the overarching library. And then once they do realize that Python is a language apart from the Pandas library, they then can go and explore all the rest of the Python ecosystem and the power in the language and the libraries that are available to them to then tie into the work that they've been doing with Pandas for their data analysis.
Absolutely. Interesting enough, this brings up, so Pandas has sort of grown up now, and in fact, we're approaching our 1.0 release. I'm not going to give a time frame because we don't actually have one yet, and this is the interesting point. Pandas now is, as you say, is one of the first experiences of a lot of people who are now coming into the Python ecosystem, whereby they're teaching in college level and high school level, and any data scientist now will want to learn Pandas, and that's actually a responsibility now of Pandas to make sure that the API that it's presenting is very Pythonic. In other words, is very readable, is very concise, and is very, at the same time does not completely obliterate, any Python rules that exist. There are some, of course, because Pandas by definition is a vectorized way of talking about things. It's an array-oriented language, built upon NumPy, and doing things in an array-oriented way is just simply different than Python. So, Pandas really does take this responsibility to heart in making sure that number one, making sure that versions are as backward compatible as possible, and of course provide flexibility and things like that. But it really is important, I think, to show the best parts of Python in the API.
As you mentioned, one of the original inspirations for Pandas was the R language and the data frame capabilities in that. And from what I've heard and spoken to people about, the Pandas data frame has actually come to surpass what is available in R. And a lot of people sort of hold that up as being the example of what a proper data frame implementation looks like. And I think that unifying abstraction is probably a big part of what has led to the success of Pandas because, well, there are a number of different inputs and outputs and analytical capabilities built into the library. They all tie into that one unifying core abstraction of the data frame and the series. And so I'm wondering if you can talk a bit more about the principle of what a data frame is, and for somebody who is just starting to come into the Pandas library, what are some of the most fundamental ideas and abstractions of that they should understand when they first start using it to work with data?
The core abstraction that is Pandas is the data frame. And a data frame is think of it as a collection of one-dimensional objects. Okay, we'll call these series. They are ordered, and they are possibly heterogeneous in data type. In other words, you can have, a couple of integer columns, a float column, a string column, a datetime column, whatever. And this is very important. So it looks naively like a columnar database is what it actually looks like. And in fact, it wears the hat of a database to some extent. You can do things like joins, you can do projections, in other words, select out certain columns, but it provides even more on top of this. One of the key ideas behind Pandas is the idea of alignment of data. In other words, if I do an operation between my data frame, which remember is basically a table-like structure, and I add, say, a series to it or something. The point is, it is going to align both of these to, say, similar, what's called indexes. In other words, the left-hand side, kind of like the dates, will be aligned. And when I say aligned, what I mean is you don't have to worry about, whether I'm off by one in the dates or not, because Pandas will naturally account for missing values in both data sets when I'm doing operations, okay? So this is another big idea. Pandas supports first-class missing value support. Not 100%, and we'll talk about that a little bit later because of some of the implementation details. But the idea being is that you can have missing values, and missing values will propagate naturally. So adding a value plus a missing value clearly gets you a missing value. And this is very, very powerful. It allows you to work with data that is not completely aligned. Okay. Furthermore, Pandas provides a very interactive experience. And you know what? Nowadays, this has become so important. The ability to just type a few keystrokes and introspect your data or change it or really just look at parts of it. So this is Pandas provides really first-class support in indexing and an ability to view your data in a very nice way. Let's see, another key feature of Pandas is the ability to work with various input-output types. In other words, everybody has, like CSV type data. Great. But maybe I want to export to, say, Excel or read from Excel or from SQL or from a binary format. And Pandas supports natively all of these formats. So in fact, some people use Pandas simply to move data from, say, Excel to SQL. And it works great for that. So just as in I was mentioning database functionality before. Well, a very important part of databases and data analysis is the ability to group by your data and perform aggregations on it. So a traditional where I form various groups and then say do a sum on those groups. Okay, so a reduction in my data set size to some sort of aggregates is a very important capability when working with databases or with Pandas data frames. And the last feature I'll say is I mentioned input-output data, but the ability to easily visualize your data is also very important. Now, Pandas does not have, all these libraries baked in, but what it does have is the ability to very simply dataframe.plot. And you will simply get a plot of your data right away. It'll just work. If I had to say the number one feature of Pandas, it's intuitive data analysis. The function names are very intuitive. The actions are intuitive. So it's natural. It's readable.
And as you mentioned, there is quite an extensive API that does do quite a good job of being easy to understand and easy to guess at. I also noticed that one of the most recent releases includes a nice cheat sheet for being able to get a high-level view of some of the different capabilities and just shortcut straight to what you need to do with it. So I'm wondering, what are some of the ways that, as a library developer and maintainer, you balance the power and flexibility of such an expressive API with any usability issues that can be introduced by having so many options available of how to manipulate the data and be able to expose in an incremental fashion the different layers that are available to users of Pandas?
It's funny, when you're managing an API, you always want a new function name to allow people to say, I want to do XYZ. Okay, so we'll give you XYZ. But at the same time, if you look at the number of functions or the number of methods that are available in the data frame, it's like over 100. So already this is too many. So I think in the last few years, we've been very, very careful about adding other top-level methods. And at the same time, we've been really, really working hard to make the existing methods really consistent in terms of the naming of the arguments, certainly the ordering of the arguments, and the basic functionality. What it says it does is what it should do. And for the most part, that was the case. However, there's a lot of as library grows and it has code contributed through various different sources, sometimes consistency can slip. And so, in fact, over the last, I'd say at least year, this has been one of the big deals, is to really, really lock down the API, make things that are, say, available on group by, available on the main API for data frames. As an example, in the next release, I've been working on adding .aggregate functionality. In other words, you can actually right now say when you have dataframe.groupby.aggregate and give it a list of functions or a function, and you can get a summarized view. So this up until now has not existed on data frames. Could you do it? Sure, you could do it, but it was not in the same way that it was natural to do. And that's the key point here, is that unlike Perl, where there's more than one way to do it, in Python, there really should be just one way to do it. And for the most part, Pandas follows that idiom. One area which Pandas does have, I'll say somewhat of a confusion, is indexing, actually. Over the years, there's been lots of, we'll say, accommodation of users because you want to provide users with all kinds of capabilities. But sometimes these can actually lead to some confusion. So another thing we've done recently is to deprecate the .ix indexer. And here's an example for people who don't really know about this. For a long time, so you have two axes to a data frame. You have, we'll call it the rows, and then you call it the columns. And so sometimes people want to do what's called label-based indexing. In fact, you want to do this most of the time. You want to look up which label you have on the rows and the columns, and then select those elements out. But there are times when you actually want to look at so-called positional indexing. And this is where you simply count from 0 to wherever on either axis. And people have tended to do as shortcuts both types of indexing. So this leads to lots of confusion, we'll say, in what's going on. And several years ago, we introduced separate so-called indexers for this, namely .lock, which is for label-based indexing, and .ilock, which is for positional indexing. And so part of this whole cleanup over the years has been to really make sure there's just one way to do things. There's not 3 ways to do it. There's just one way. So we'll get there. And I think once we get there, we're going to have a 1.0 release. So it's going to take a little bit more time. But I think that the API is really very important. And I think if we have to take a little bit more time to get to a really solid API that we're not going to then change, that's worth waiting for.
As you mentioned before, Pandas is strongly focused on being used in data science and data analytics and physical sciences, but there are also a number of areas where Pandas is useful as well. So I'm wondering, what are some of the most interesting or unexpected uses that you've seen or heard of?
So it's funny, one of the biggest uses I suspect Pandas is for out there are things like log parsing. And here's the funny thing about this. I always say this when I'm doing a talk in Pandas. I say, we have lots of discussions on issues, on our tracker. And there's always people who want to comment on certain certain things. And repeatedly they come up and talk about those specific issues. The funniest issue I've ever heard about is, Pandas has really first-class support for not only timestamps that are naive, in other words, they don't have a time zone, but timestamps that have a time zone, okay? And time zone arithmetic itself is actually fairly complicated. There's a lot of edge cases and things like that. So over the years, we have, I'll say, 3 or 4 contributors who their sole purpose is to comment on issues related to daylight savings time transitions, which is a very funny thing because we have 2 of them per year, in the U.S., of course, but there's transitions in other time zones and other countries and so forth. But the very funny thing is this is a non-trivial thing because, of course, in a transition you have, either times sort of repeated or it's skipped. And so how to handle, and especially when you have log data, like example, advertising log data, it of course goes through these times. Financial data rarely does, but other types of data does. So it's very interesting where you have applications into very, very specific type of areas that are, not physical science and not financial applications. So that was just one point.
I'm not sure if you've come across this, but there's actually quite a long and humorous list of contradictory beliefs that programmers have about time. And having had to deal with time zones and timestamps in quite a number of applications, I can sympathize with the people who have to keep educating others on the challenges that are posed by that.
Yes, absolutely. Funny thing is, this is the one great thing, not one great thing. There's a lot of great things about the Python ecosystem. The first thing that I always point to is the fact that the libraries and the great breadth and depth of the Python ecosystem is just amazing. There's a package for everything you can think of. And that is so great, actually. You can just, whatever problem you have, the very first thing you do is look for a package that solves exactly that problem. And, 9 times out of 10, you'll be able to find one, which is great. So, in fact, this is another, I'll say, hard problem, actually. Finding, you have packages which form the core of the Python ecosystem. And Pandas is one of those in the PyData stack. But at the same time, it is useful from a user perspective to have lots and lots of functionality. So, as an example, Pandas could, for example, split off its time series functionality or something. And that would be fine. I mean, we could make it so that Pandas users can still use that, of course. And nowadays, installation of packages is not so hard. But I really think that having a common and curated API to a large part of the data analysis stack is really, really key. Conformity and uniformity is not something that you would think is very important, but in some sense, I'll just give my one dig about R here, is that in the R ecosystem, there are packages for everything, and you don't know the quality of them, and you don't know how they're maintained and how they work together. So it actually behooves Python to really spend a lot of effort, and I'm talking collectively here, in having high quality core packages, and it does.
Yeah, it's definitely a challenge, particularly coming in as a new user to a particular ecosystem or set of tools, to have that uncertainty as to the level of quality of what's available, or not really understanding what are the canonical packages for any particular capability. And yeah, if you do have a well curated list, or at least reference material that somebody can look to see as a sort of launching point, what are the packages that I would use to at least get started with this particular set of capabilities, it's immensely valuable. And the fact that Pandas and NumPy are such strong cores of a huge portion of the Python ecosystem, even beyond just data analysis, I've seen it reach into areas including web development and just back-end systems engineering, because of the fact that numerical capability is such a far-reaching use and need within any program, that the fact that we do have such powerful packages that are well respected even beyond the Python ecosystem itself speaks volumes about what people can do with Python and what people have done with Python.
Absolutely. And actually, that brings up a very good point. It's interesting. Python is actually really well known, not necessarily for data analysis. Obviously, that's a key point nowadays. But web development is huge. And the interesting point about that is that now I see more and more web developers actually starting to reach for Pandas to do their, hey, they want to throw up a table, or they want to do some simple stuff in their UIs. They reach for Pandas to do this. And in fact, we are also having a lot of interest from actually the front-end developers. In other words, things like the Jupyter developers, to integrate more with Pandas, because everybody wants to have their data frame and to have it. And of course, what they really want is to have an interactive data frame, that scales and they can flip the columns around. And so this is all coming. This is the next thing that's going to happen, is in the notebook, starting in the notebook, you will have really first-class data frame support for manipulation of your data frames. And it's going to go both ways, too. So, making changes in the front end will reflect back in the back end. So this is really coming. And it's exciting because, this is, I think, taking your data and putting up a graph, that's been going on a while. And you can do, there's a lot of great packages for this, but really first-class table support is, that's really, really well integrated in the Python ecosystem. And I'm not saying writing all this custom JavaScript, but I'm saying really first-class in the Python ecosystem is coming.
Yeah, I think another aspect of Python, and particularly in the data analysis space, is the fact that we, as a community, are very outward looking, where we don't try to lock people into doing everything within Python. We actually try to provide a lot of outlets for people to use it as a waypoint, or even to migrate from Python to other languages, because we know that by locking people in, people are less likely to want to even start using Python. And one of the more notable recent developments in that front is the Feather library that wraps Apache Arrow and allows easy interoperability of data frames between Python and R. And I think that that's one of the really powerful lessons that Pandas as a community in particular really carries out.
Absolutely. And just commenting on that, this is going to go even further. So actually, Wes is currently hard at work, we'll say, on re-engineering some of the, we'll say, base levels of, not even Pandas at this point, just some base, it's called Arrow, is his new project, or PyArrow, which is essentially, the goal is to provide a very convenient format, we'll say, that you can exchange data in memory between various things, namely things like Spark and Pandas. And so this will facilitate, movement in memory. And so Feather is just an offshoot of this, actually, and it's going to be soon rolled back into Arrow, so that there will be effectively a standard for exchanging data in memory and on disk between various different, not necessarily formats, but between various different memory processes. So an example, it'll be very convenient for you to use PySpark and then push your data to Pandas in a very performant way. And that's the key point here, is that Pandas is great, it's very performant itself, but when you put it in a so-called big data framework, there's some translation barriers here that exist right now. And so Wes is hard at work actually on re-engineering some of this low-level basic infrastructure in order to facilitate a much more performant data frame. And so actually this leads me to the next generation of Pandas. We're going to call it Pandas 2.0. Even though we've not officially blessed Pandas 1.0, there is a notion of Pandas 2.0 where we're going to re-engineer we'll call it the back end of Pandas. So the idea being that 95% of the API, the user-facing API, is going to be unchanged. Okay, only specific edge cases, which right now are even in fact not possible. So here's an example. Right now, it is not possible to represent NA for integers. Pandas simply converts them to floats right now. Okay, because the implementation of Pandas is in NumPy and it's just not supported there. So Pandas 2.0 will have first-class support for all data types, including integers. So example, this is going to fall in the small percentage of API which is we're going to break to support this type of functionality. So, but however, we're going to be able to do almost this entire, we'll call it back-end implementation change, where things will be faster, be flexible, and be more supported than even they are now without changing the user experience. The hope is to have very close to drop-in replacement. And so give us some time, but I think this is an exciting development for Pandas because Pandas will really be able to take its place as a first class. It already is a first class, but even more first class, we'll call it, user experience and the ability to then interact with the rest of the world at large in a better way.
And what are some of the biggest challenges that you've encountered while working on and maintaining Pandas?
Well, the biggest challenge really is, so we have a fair number of contributors. We have, of course, the drive-by contributors, but we also have some people who've done some patches that are, well thought out and fairly invasive. But the biggest problem is that Pandas is a fairly large and sprawling code base. For people to, that's sort of a double-edged sword. They can work on a portion of the code, in other words, something that interests them. Maybe they're interested in a bug in Excel. Well, our Excel interface is not that complicated, and they can dive in and figure it out. So that's great for new contributors, actually. What the biggest challenge, I would say, is having a group of people who can make, I'll say, somewhat far-reaching changes. In order to really make significant impacts nowadays, you really have to understand a fairly large part of the code base. Yes, there's a lot of peripheral parts which are sort of self-contained, but in order to make some far-reaching changes, in other words, to make anything related to, say, indexing, you have to really dive in. And that's been the challenge, is having people who can do that and correspondingly other people who can review that code. And so up till now, it's been a fairly small group of folks there. So I would say that's probably the biggest challenge.
And what does the internal software architecture and design look like that it enables such broad functionality and it allows for multiple people to be working on the code base without stepping on each other?
So Pandas actually has been really quite accessible, I think, to people. It's right now, say about, 75% Python code and maybe, 20%, say, Python code, okay? And, a small percentage of just pure C code. Interestingly, in our new version, this will flip-flop and you're going to have a large percentage of the code base in C++, and Python will become much more of a thin wrapper. So ironically, this will actually make it a little bit harder actually to contribute to the code base because it's very easy to tinker in Python or even Python code.
And is it a fairly modular code base where it uses sort of a plugin architecture for being able to load in the different import and export interfaces?
So the architecture is, we'll say, somewhat modular. As far as the input-output layer, yes, that is very, very modular. Actually, adding or chopping off a module is fairly easy. In fact, over the years, so we had some folks who added, example, an interface to Google's BigQuery that was directly written in the Pandas code base. And actually, that was one thing. We're just going to split that off into its own separate package so that those folks can then work on it independently, yet it will still work with Pandas directly. So things like input-output adapters are very modular. Fortunately or unfortunately, other parts of the code they're fairly well designed and they're very well tested and they're organized, but they're not super modular, I'll say. Although, over the years, we have become a lot more friendly to things like subclassability. So there are folks out there who have wanted the ability to subclass, series and data frame, and it is certainly possible nowadays. I normally don't recommend it, but there are a few cases where it actually is useful. So Pandas is becoming, along with becoming more consistent in the naming of parameters and method names and things like that, we have become, I'll say, more covered in terms of, inheriting from common base classes and things like that. where it is at least, approaching pretty well designed code.
And jumping back out to the higher layer, do you find the constraint of only supporting two-dimensional arrays to be in any way limiting, or do you think that that has proven to be beneficial for the success of Pandas because of the fact that there is that constraint placed on the way in which the data is interacted with?
So Pandas is named from panel data arrays, okay? And a panel is in Pandas land is a three-dimensional array. But we've been actually moving away from this. And in fact, we're going to deprecate panel pretty soon. I guess people will be sad, but three-dimensional data is far less common than, say, two-dimensional or one-dimensional data. In fact, you can certainly represent three-dimensional data as a multi-index with two-dimensional data. So this is up till now, has been a very, very common way of doing things. Also, there's we'll call it a sister package called Xarray, which is built entirely on top of Pandas, which is designed for handling n-dimensional, we'll call it data frames. In fact, these are the folks who do weather data, which is naturally like 4 or 5 or 6 dimensions or whatever, designed this for this reason. So we are very happy to sort of spin off, like you call it, panels, because the implementation just becomes that much more complex. Indexing becomes that much more complex. And the vast majority of things people are doing are really in 2 dimensions or 1 dimension. Going to 3 is not. Yes, it certainly happens, but there are a lot of ways to represent data. So to answer your question, I don't think it's really a problem.
So are there any other topics or questions that we haven't covered that you think we should touch upon?
Sure. I just want to briefly talk about Dask, just very briefly. So Pandas is primarily, effectively, an in-memory vehicle for doing data manipulations, just as NumPy is a in-memory system for array manipulation. So there's another package called Dask, which is, in effect, a distributed data frame and also a distributed NumPy array. So this is when people come to me and say, I have lots of data, or I want to work on multiple cores, what do I do? Well, the very, very first thing I will say to them is to use Dask. If you really do have, multiple cores and you want to process your data, simultaneously across multiple cores on your machine or even across a cluster. And the idea here is that Dask is built upon Pandas and NumPy. And effectively, it is a scheduler or a coordinator of data frames that exist on each core. And so this is a very, very powerful way of thinking about what you're doing. It allows you to use the natural Pandas syntax. In fact, Dask mimics and mirrors a lot, not all, but a lot of the Pandas syntax for this exact reason. So it's an API in itself now that allows you to perform operations, not just, so with a single data frame, of course, we have vectorization. We can do df.sum, but if I have a Dask data frame, I can do the same thing, but now I can do that operation across many cores. So this is a very powerful way of thinking about and working on my data. It gives a feel of like a Spark or a Hadoop type feel where I can actually then control where the operations on my data frame and the data doesn't move around is the whole idea here. So this is a very powerful abstraction, and this is the way, I'll tell you, this is the single way that people can extend the processing power of Pandas. There's not really, yes, Python has, threading and has multi-processing, but this is a very powerful and native way. It's all pure Python code to be able to work on distributed data frames. And I think this is a really powerful way to move forward.
Yeah, and for people who are interested in learning more about that, I actually did a really interesting interview with Matthew Rockland, the maintainer and one of the primary contributors to the project, on the Data Engineering podcast. So I'll add a link to that in the show notes as well. But it was definitely interesting hearing about how Dask does a good job of sitting in between projects such as Spark and Airflow in terms of its capabilities and use cases of being able to do directed task graphs and distributed in-memory computations of data, and being able to do it purely in Python and tie into the broader Python ecosystem as well. As we've touched on a few times, Pandas is a fairly integral part of the overall Python data ecosystem, and as such, it's very important to a number of people for being able to do their day-to-day work. I know that NumFocus is the fiscal sponsor for PyData, so I'm wondering if you can talk a bit about the long-term prospects of Pandas as a component of the day-to-day work of that large number of people, and how they can be sure that it will continue to be supported and maintained and developed for them to be able to continue using it.
Yes, so Pandas became NumFocus fiscally sponsored about a year and a half ago, and this allowed us to accept donations, and we've had a number of donations to date. And in fact, we're actually embarking on a round of fundraising now to fund some efforts to support Pandas 2.0 and, of course, maintenance costs. I mean, this is the big thing about the open source. Generally, a lot of the big packages have had, say, a single developer or a couple developers driving the initial creation and expansion of the packages. And it's not any different with Pandas. And that's great until, they change focus and move on or something else happens. And so the longevity and the long-term health of a project is actually hard. And, there's different stages of these projects. I mean, Pandas has been in the grassroots massive expansion phase for quite some time. I think we're getting to a phase where, there's not going to be major new features added. There just simply aren't, because we have a lot of the features that are required. And it's now a time to, fix bugs and even improve the actual excellent documentation now and improve testing. These are almost boring things, but they're very, very necessary things for a widely used project. And so it actually is very important that not only Pandas, but things like NumPy and a lot of other PyData projects are part of NumFocus, so that we can receive funding for things like maintenance and even earmarked toward new features and things like that. So,
well, it's definitely a very useful package, one that I've used a number of times, even for just small little ad hoc queries, because it's easier than trying to dump it into even a SQLite database. So I'm definitely glad that I can expect for it to be here long into the future.
Pandas is my first tool for everything. It is just really convenient to be able to work with data in the very, very natural way. I mean, it's just built for doing, slicing and dicing your data. And, one thing I compare it to is, I've seen lots of people do, I have my data sitting in some SQL tables as an example. And, it's in a nice form. So, let me just do, a giant query in there. And, you send the query off, and some point later you get some results back. And it's just not interactive necessarily. And so I like to use it in concert. Generally I like to simply pull the data into memory. Generally we're not talking about, ginormous amounts of data here. So it's pretty reasonable to do this. And then I have the data at my fingertips. I'm sitting, in my notebook, and I can slice and dice it how I want, play with it. And then, if I really want to, do some sort of aggregation in the SQL server, well, I can do that. But doing anything more than very, very simple, reductions it's just much easier to do in memory. And so I find that it just flows. It just makes it really easy. The ability to, chain expressions. In other words, I can, take my data, and then I want to slice it, and then I want to do a group by, and then I want to do, maybe, a couple of aggregations. Oh, and by the way, then I want to plot the data. Okay. Or maybe I want to push it out to another package. It's all very easy. It's nice to read. It really is. And that's one of the key things. I see, so I sort of see kind of two uses of Pandas. One is actually taking quote unquote clean data and then performing various transformations and aggregations on it. But a very, very important use of Pandas is cleaning up your data in the first place. So, what ends up happening is, you have, data source XYZ, and it's a CSV file. But the headers are, I have to do some transformations on them, and my dates are all screwed up. Okay, let's go fix that. But that's the point. I can write a little make a little wrapper function and read in this god-awful messy CSV, clean it up, drop the bad rows, and just give it into some nice format. And then poof, out of that function, I have a nice clean data frame that I can then do my aggregations and transformations on. It provides a nice, barrier between various operations here. So I think it really behooves people to understand the different parts of data manipulation. I mean, one of Pandas' hallmarks is the so-called ETL, or extract, transform, load. This comes from not even the big data world. I'll say it's the big iron world, where you have your data sitting in some big data lake, and you need to extract it and then process it and then push it somewhere else actually. So Pandas can serve you in various levels and various capacities as part of this. What I say to people is your goal is to set up a pipeline, and the pipeline is take your data in its raw form and transform it to another form, whether it's on disk or in memory, it's a graph, whatever it is. And you will have a pipeline of steps to do this. And I'm convinced that, and I hope you are too, that Pandas can help at virtually every one of these steps. It's just a way of taking data and transforming it in various ways without writing loops and without doing all kinds of crazy manipulations, and it just allows you to think about your data, or it allows you to box your problems. So say one box is taking this raw messy data and transforming it, reading it and transforming it. Box 2 is taking it and aggregating, reducing it, whatever. And then box 3 is a graph, and it allows you to attack these problems in various stages without having to worry about all the other problems at the same time. It allows you to really focus on what's important.
For anybody who wants to follow you and the Pandas project and keep in touch with what's going on, I'll ask you to just send me the preferred methods of contact and the preferred information sources. So I'll put those in the show notes. And with that, I'll move us to the picks. And my pick this week is a bit of documentation from a game studio called Mousepaw Games that I found to have a lot of good ideas in terms of code style, but the I think most interesting and useful aspect of their standards is something that they called comments showing intent, which they abbreviated as CSI. And it's just a way of, as you're working on your projects, making sure that the comments in the source code are informative enough that you could actually take all of the code out, just have the comments, and then be able to re-implement the original program without a whole lot of difficulty. And the purpose behind that being that it makes it easier for somebody new to the code base to come in and actually understand what's going on without having to necessarily look through reams of documentation if they're only focused on one particular portion of the code. So definitely recommend people take a look at that and see if there are any ideas that they can pull out of it for their own day-to-day work. And with that, I'll pass it to you, Jeff. Do you have any picks for us?
I'll just say this was something I was working on today. This is not even a package. This is so when you're developing your own packages, it's of course very important to test things. And again, this comes down to almost boring things, but boring things are really important when you're building an actual real project. So I will just quickly mention the 3 testing sort of things that, there's actually more than 3 things that Pandas uses. So we use these so-called continuous integration services, one of which is Travis CI, which basically all of these work sort of similarly, where we basically have for lack of a better way of telling this, we have a control file, and it takes every single commit, all of your code gets pushed to these services, and they run with a certain configuration and then run all your tests. So we use Travis CI for testing on Linux and testing on Mac OS. We use something called appfair.com for testing Windows. And today, actually, I wrote an interface to another Linux testing service called Circle CI. In fact, the reason I was doing it was because we actually test so many different configurations. I think we have like 15 different configurations that we test. In other words, we have things like, we test on, Python 2.7 and 3.5 and 3.6. And we, of course, have various different combinations of libraries or dependencies that we use. So we have so many different combinations. We try to hit everything. And it's just taking so long to run these builds. It takes like 4 hours to run them, for every single combination. So we're trying to offload some of the capacity to some other services so that we can then ensure testing compatibility. The one other thing I'll mention here is that, and this, Tobias, this goes along with your library that you just pointed to. So Pandas, about a year ago, we implemented this linting service. So we actually do, one of Python's big selling points is the fact that you can look at code and instantly understand, the line breaks and where functions start and where functions end and all these kind of things, because it's a formatted language. But it's not exactly the same formatted language between 2 different people even. So about a year ago, we implemented a linter, and a linter is just simply a style checker. It's something, that makes sure your lines have, 80 characters or less, and, things like that. And it's sort of a silly, boring thing, and people hate when they break it. But you know what? It really makes your project compatible. It really makes it easily understandable and digestible, from file to file, because they're all the same exact format. And, in a little project, maybe this doesn't matter. But as your projects grow, this is extremely important. And I think that you should just do it.
Yeah, I could definitely agree with that. Having consistent conventions within a project and having them enforced definitely makes it easier for people to come in and be able to contribute. Because if you have 5 different styles within a single file, then then it can be really jarring and difficult to actually gain a cohesive picture of what's going on. And for people who are interested in learning more, I'll point them to the interview that I did with the folks behind the Pilot library, and I'll add a link to that to the show notes. Well, I really appreciate you taking the time to join me today and share your work with Pandas and all the wonderful things that it can be used for. It's definitely a useful package, and it was a very informative conversation. So thank you for taking the time.
Thank you very much. I had a nice time doing this.